Hello there, and welcome to the Night Channel. Tonight, we are turning our attention upward to one of the oldest companions in the human story, the full moon. For thousands of years, people have stepped outside on bright nights and felt the same quiet sense of wonder. A pale world hangs in the darkness above us. It brightens fields and rooftops. It rises as the sun slips away, and somehow it always feels both familiar and mysterious at the same time. Yet, the full moon is far more than a beautiful sight. It is a moving world of rock and dust that reflects sunlight across thousands of miles of space. It shapes ocean tides. It has guided calendars, festivals, and travelers. Long before electric lights soften the night, its light has changed the behavior of animals, inspired myths in every culture, and revealed clues about the deep history of our solar system. So, tonight, we will wander through the science, the history, and the surprising secrets that hide behind the bright round moon in the sky. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is settle in. Let your body soften, and allow your eyes to grow heavy. And as the day begins to gently drift away, join me as we explore the full moon together. Let's begin. A full moon is never truly full for more than a moment. That bright round face seems steady and complete for an entire night, but the perfect alignment is brief. The moon is always moving through space. Earth is moving too. So, there is one precise instant when the side turned toward us is most fully lit. Before that instant, a tiny sliver is still missing from one edge. After it, the same is true on the other side. Our eyes rarely notice, because it is delicate, but a star on me does. This makes the side more interesting, not less. What feels fixed is actually a snapshot of motion. It is like trying to catch a spinning dancer. At the exact moment both arms are open, widest, you may think you are seeing something permanent, but you are really seeing timing. The full moon teaches that the sky is not a painted ceiling. It is a clock of moving worlds, and even its calmest scenes are alive with change. The full moon rises as the sun sinks below the opposite horizon. That is one of the sky's most elegant arrangements. As daylight fades in the west, the bright moon appears in the east, almost as if one great lamp is taking over from another. People who do not usually watch the sky are often surprised by this. They imagine the moon can appear anywhere at any time. In truth, the full phase has a beautiful logic. It happens because the moon stands opposite the sun from our point of view. That is why sunset and moonrise become partners. If you stand somewhere with a wide view, a beach, an open plain, a high hill, you can sometimes watch the handoff happen almost in real time. One side of the world warms with the last gold of day. The other receives a pale disk, climbing into darkness. It feels theatrical, but it is really geometry. The drama comes from the earth turning, and from us riding that turning ground. The familiar dark patches on the moon are ancient lava plains. Those broad charcoal regions on the full moon were once called seas, because early observers imagined they were vast bodies of water. The old names remained, which is why we still hear titles like Sea of Tranquility or Ocean of Storms, even though no liquid ocean lies there. In reality, those darker areas are immense plains of basalt, formed when molten rock flooded low regions after giant impacts opened the way. That means the dark markings most people recognize with the naked eye are the cooled remains of ancient volcanic episodes. They are not simply stains on the moon's face. They are evidence that the moon was once far more geologically active than its silent appearance suggests today. This changes the way the full phase can feel. The dark patterns are not decorative shapes. They are frozen lava landscapes spread across an airless world. Every time we look up and recognize them, we are seeing the remains of lunar fire from the distant past. The full moon looks enormous near the horizon, but this is an optical illusion. This is one of the most famous deceptions in the sky. When the moon first appears above distant trees, rooftops, or hills, it can look vast enough to stop you in your tracks. People often assume the atmosphere magnifies it. It does not work that way. In fact, the moon can be slightly smaller to your eye near the horizon, because it is farther away by a tiny amount. The real change happens in your perception. When the moon is low, your brain compares it with familiar objects on Earth. Chimneys, fields, towers, and roads give it a sense of scale. High overhead, that comparison disappears, and the same moon seems smaller. It is a reminder that seeing is not passive. The mind is always interpreting. That makes the experience more fascinating, not less. The huge horizon moon is a collaboration between astronomy and human psychology. The sky provides the object. Your brain quietly builds the grandeur around it. Every full moon shows us the face that Earth has known for years. We never see the moon's far side from the ground, because the moon turns on its axis in the same time it takes to orbit. That keeps one hemisphere aimed our way. So, when the disk becomes full, the familiar pattern of dark plains and brighter highlands is the same arrangement people looked at thousands of years ago. Ancient farmers saw it. Sailors saw it. Poets, emperors, shepherds, and children saw it too. Entire civilizations built stories from that one enduring face. Some found a rabbit there. Some found a man. Some saw a toad, a woman, or a bundle of wood. Modern spacecraft later revealed the hidden far side, but the side we know remains the old public face of the moon. There is something moving in that continuity. Human history changed beyond recognition, yet the same lunar features kept returning above us. The world below transformed. The face above remained, waiting to be recognized again. The full moon can pull ocean tides higher, even from far away. The moon seems distant and serene, but gravity reaches across that gulf without effort. Its pull does not simply lift the sea in one place. It helps create bulges in Earth's oceans. And as our planet turns, coastlines move through those bulges and experience tides. Around the full phase, the sun, Earth, and moon are arranged so that lunar and solar gravity work in stronger partnership. The result is a set of especially pronounced tides called spring tides. They do not mean springtime. The word refers to a rising or leaping motion. Harbors can feel the difference. Mudflats vanish beneath water. Currents run harder through narrow channels. Shorelines breathe more dramatically. This is one of the most wonderful things about the full moon. It is not merely a sight. It is an influence. You can look up and then look down at the sea, knowing the same celestial arrangement shapes both. Light reaches your eyes. Gravity moves the water. Ancient people used the full moon as a calendar written in light. Long before printed calendars hung on walls, the sky offered a repeating signal that almost anyone could track. The moon changed shape night by night, and the bright round phase became an easy marker in the flow of weeks and seasons. Communities could remember when to gather, when to travel, when to hold ceremonies, and when certain natural events usually return. This did not require advanced instruments. It required attention. The cycle was visible, dependable, and shared. A child, a hunter, or an elder could all look upward and know roughly where they stood in the month. Over time, full moons gained names tied to weather, harvests, animals, and seasonal work. Those names were not random poetry. They were memory tools linked to survival and rhythm. In that sense, the moon was not just observed. It was read. It offered a kind of luminous bookkeeping for human life, and many cultures built entire systems of time around its repeating brightness. The full moon feels close, yet it is about 250,000 miles away. That tension between intimacy and distance is part of its spell. The moon appears large enough to feel companionable. It rises above your own neighborhood. It shines on your own roof, your own trees, your own street. Yet, it is astonishingly far from Earth by everyday standards. Cars, ships, and planes are useless comparisons at that scale. Even light, the fastest thing we know, needs more than a second to bridge the gap. Human beings cross that gulf only within living memory, which still feels almost unbelievable. Astronauts looked back and saw Earth hanging in black space, while the moon beneath them was no longer a symbol, but a real place of dust and stone. That is the wonder of the full moon. From it belongs emotionally to ordinary nights, but physically it is a world apart. It teaches distance in a strangely tender way. Something can feel near to the heart while remaining vast, remote, and almost unimaginable. The full moon happens when Earth stands between the moon and sun. That arrangement is the hidden machinery behind one of the most familiar sights in the sky. The moon does not decide to glow more brightly on its own. What changes is the angle. When our world lies between the sun and the moon, the lunar side facing us is bathed in sunlight, and the disk appears round and complete. It is a simple alignment, yet it creates an effect people have treated with reverence for thousands of years. You are looking at a world illuminated, because we happen to be standing on the correct side of our own planet, at the correct moment in its turning. That means the scene depends on relationship. Sun, Earth, moon, and observer all matter. The beauty is not separate from the geometry. It is born from it. The next time that bright circle rises, it is worth remembering that its fullness is not a property of the moon alone. It is a brief arrangement of three worlds. At full moon, the lunar surface is lit almost straight from behind us. That is why the face of the moon can look so broad and open, yet also strangely flat. The sunlight is coming from nearly the same direction as our gaze, so mountains and crater rims cast much shorter shadows toward our eyes than they do in other phases. Imagine walking through a city at noon instead of late afternoon. Buildings still have shape, but the dramatic long shadows are gone. Something similar happens on the moon. This is one reason a full disk can feel different through binoculars or a small telescope than people expect. They imagine the brightest phase will also be the most rugged. Instead, some of the relief softens. The world looks illuminated in a more direct and revealing way, yet some of its sculpted character becomes harder to sense. That makes the full phase fascinating for a different reason. It teaches that light does not only reveal surfaces. Depending on the angle, it can also hide the depth and drama carved into them. Astronomers often avoid the full moon when hunting the faintest objects. For professional observatories and backyard stargazers alike, bright moonlight can be a real obstacle. When researchers want to study delicate galaxies, dim nebulae, or the farthest reachable smudges of the universe, darkness matters. Every extra bit of sky glow makes those faint targets harder to detect. So, telescope schedules often bend around the lunar cycle. The brightest phase is excellent for studying the moon itself, but less helpful for chasing the whispering light of remote objects. There is something poetic about that trade-off. The nearest celestial body can make the distant universe harder to see. One familiar face in the sky can drown out ancient photons that have traveled for millions or billions of years. It is a reminder that astronomy is not only about powerful instruments. It is also about timing, patience, and choosing the right night for the right question. Even in modern science, the moon still sets the terms of what the dark will allow us to find. A full moon rises later each day by roughly 50 minutes. That steady delay is one of the clearest signs that the moon is traveling eastward around Earth, while Earth is also spinning. If our planet merely turned beneath a fixed moon, moonrise would come at the same time every day. But the moon has moved along its orbit, so Earth must rotate a little longer before that bright world appears again above the horizon. The result is a daily shift. People can notice without any instruments at all. Watch carefully for a week, and the pattern becomes unmistakable. A moon that climbed early one evening may not appear until much later, a few nights afterward. This simple change connects ordinary observation to celestial motion in a beautiful way. You do not need equations to sense that something grand is happening. The schedule itself gives the game away. The moon is not hanging still above us. It is advancing through space, and each delayed rise is a quiet message from the orbit that carries it onward. Some full moons seem golden because moonlight crosses thicker evening air. When the moon first rises, its light must pass through a much deeper layer of atmosphere than it does high overhead. That longer path matters. Along the way, air, dust, and tiny droplets scatter away more of the shorter blue tones, leaving warmer colors to dominate what reaches your eyes. The result can be a rich golden moon that feels almost unreal above fields, roofs, or distant hills. It is not changing into a different world. The change is happening in the air between you and it. This is one of the pleasures of moonrise. The sky can turn a familiar object into a temporary surprise. A pale silver disk later in the night may have looked almost amber at the horizon an hour earlier. That shifting color gives the full phase a sense of drama. It reminds us that seeing the moon is never only about the moon itself. Earth's atmosphere is always part of the performance, shaping the light before it arrives. A red full moon near the horizon owes its color to Earth's atmosphere. The deeper that low moon sits in the sky, the more air its light must struggle through before it reaches you. That journey strips away more of the shorter wavelengths and lets redder tones survive more easily. The same basic process helps explain vivid sunsets. In both cases, the atmosphere acts less like empty space and more like a filter. Smoke, dust, humidity, or pollution can intensify the effect and push the color from warm gold toward copper or even a striking reddish orange. This can make a rising moon look dramatic enough to seem ominous, which may help explain why red moons have stirred human imagination for so long. Yet the cause is not supernatural. It is physical, local, and beautifully understandable. You are not seeing the moon change its nature. You are seeing our own planet alter the light. In that moment, Earth becomes part of the image, painting the moon with the colors of the air around us. The full moon often looks sharper in cold air than in humid air. Anyone who watches the sky across seasons can sense this difference. On crisp winter nights, the moon can appear etched into the darkness with startling precision. Crater patterns look cleaner. The edge of the disk seems harder and more exact. In warm, humid conditions, that same bright face may look softer or slightly smeared, as if seen through a thin veil. Moisture in the air scatters and blurs light, and turbulent layers can make details shimmer or tremble. Cold air is not always perfectly steady, but it is often clearer and drier, which helps the moon stand out with greater definition. This is one reason bright winter nights can feel so unforgettable. The world is darker, the air bites harder, and the sky seems to reveal itself with extra honesty. You're still looking across hundreds of thousands of miles of space, yet the difference between sharpness and softness may come down to the state of the air just above your own skin. Not every month brings a full moon in the same season. The moon keeps its own rhythm, and that rhythm slides against our calendar in ways people do not always expect. A year is built around Earth's journey around the sun, while the sequence from one full phase to the next follows the moon's cycle instead. Those two clocks do not divide neatly into one another. Because of that, the date of the full moon drifts through our months and seasons rather than landing in one fixed place. A bright, round moon that arrives in deep winter one year may visit much earlier or later in the season another year. This movement helped make lunar timekeeping feel alive rather than mechanical. Festivals, agricultural traditions, and religious observances had to pay attention. The sky was not following the tidy squares of a printed planner. It was following celestial cycles that braided together without perfectly matching. That mismatch is part of the beauty. The moon repeats, but never in quite the same calendar slot, which keeps each year subtly fresh. The full moon is the brightest natural light in Earth's night sky. On a clear night, far from city lamps, that brightness can feel almost unreasonable. Fields reappear, tree lines sharpen, paths return. Human eyes, which struggle at first in darkness, begin to work in a different way under that silvery light. It is not close to daylight, yet it is strong enough to change how the whole world feels. This is why bright moonlit nights shaped human life for so long. People traveled by them, watched the land by them, and measured time by them. Even now, when most of us live under electric glow, a bright moon can still command the sky in a way no star can match. Venus can sparkle, Jupiter can gleam. Nothing else natural overhead fills the landscape with light the same way. It is one reason the sight feels ancient. It once mattered to survival, and some part of us still remembers that. Full moonlight is sunlight reflected from a worldless desert of rock. That alone can change how the moon feels. What looks soft and silver is not its own glow. It is sunlight that left the sun, crossed space, struck an airless surface of dust, stone, broken crater rims, and dark volcanic plains, then traveled onward to your eyes. In other words, moonlight is a journey. It begins in the furnace of a star and ends in a quiet night on Earth. The surface that sends it back is harsh beyond ordinary experience. There is no wind there, no rain, no trees, no seas, just old scars, powdered ground, and an immense silence. Yet, from that severe place comes one of the most beautiful lights we know. That contrast is part of the wonder. The source is violent. The landscape is barren. The result on Earth can feel calm enough to walk by. Beauty in the night sky often hides surprising origins, and the moon is one of the finest examples. A full moon in winter rides higher for many northern observers. This surprises people because winter often feels like the season of low sun and long darkness. Yet, that very geometry helps lift the full moon. When the sun takes a low path across the southern sky in the northern hemisphere, the opposite point of the sky rises higher at night. Since the full phase appears opposite the sun, it often climbs on a loftier arc. That can make winter moon rises feel unusually grand. The moon clears trees and rooftops more decisively. It spends more time high overhead. Its light can spread broadly across frost, snow, or bare ground, making the whole season seem more luminous. For people in colder climates, this may be one reason winter moonlight feels so memorable. The nights are long enough to hold it, and the moon's path can carry it well. At the darkest time of year, the sky can answer with one of its brightest and highest nocturnal displays, which feels almost like a seasonal gift. A summer full moon often stays lower and softer above the horizon, where winter full moons can climb with confidence. Summer ones in northern latitudes often trace a humbler route. They rise and drift along a lower path, never seeming to escape the company of trees, hills, and distant buildings for very long. That low track changes their character. Warm air near the ground can blur the disk. Haze can tint it gold or amber. The light can feel thicker, more atmospheric, and less stark than in colder months. It is the same moon, yet the season alters the performance, following it over the year. The sky does not present the full phase in a single standard form. It offers variations. A summer moon can feel slower, heavier, and more entangled with the landscape. It lingers in the lower reaches of the night, where heat, dust, and humidity reshape its appearance. In that sense, season becomes part of the show, and the horizon becomes an active partner in what we see. Thin clouds can turn a full moon into a glowing silver lantern. When wisps of cloud drift across a bright disk, they do not always hide it. Sometimes they transform it. The moonlight spreads through the thin vapor and creates a soft, luminous bloom that can make the whole sky around it seem alive. The effect is less like a spotlight and more like a lantern seen through fabric, bright at the center and diffused outward into a floating halo of silver. This can be far more atmospheric than a perfectly clear view. The moon becomes less a sharp object and more a radiant presence suspended in the dark. Painters and storytellers have long loved that look because it feels at once earthly and unearthly. What causes it is simple enough. Tiny droplets and ice particles in the clouds scatter the light and spread it outward. Yet the result can stop people in their tracks. A familiar full moon becomes theatrical, and the sky seems to gain depth, softness, and mood in a single moment. Ice crystals can wrap a full moon in a pale circular halo. High above the ground, thin veils of icy cloud can fill the sky with countless tiny crystals. As moonlight passes through them, the crystals bend the light in very specific ways, and a broad ring can appear around the moon. This halo is usually large, faint, and ghostly white, though careful eyes may sometimes glimpse a trace of color. It can look so clean and perfect that it seems designed rather than natural, like a great compass had drawn a circle around the moon in light. The science behind it is beautiful because it depends on shape. Many of those crystals are six-sided, and their geometry helps produce the ring. So, a halo is not random decoration. It is optics written across the sky by falling ice, too small to see individually. That is part of the wonder. Something delicate and near invisible above your head can generate one of the grandest patterns in the night, vast enough to frame the moon itself. That bright halo around a full moon can hint at changing weather. For centuries, people noticed that a ring around the moon often seemed to arrive before a shift in conditions. The old saying about a halo warning of rain did not come from nowhere. Those glowing circles are commonly caused by thin, high clouds filled with ice crystals, and such clouds can travel ahead of approaching weather systems. So, while a halo is not a guarantee of rain, it can be a real clue that the atmosphere is changing. This makes the sight more than decorative. It can be a message. Long before satellites and weather maps, people read signs like this with seriousness. Because the sky affected travel, harvests, and safety, the moon became part of practical observation as well as wonder. There is something satisfying about that blend. A beautiful optical effect can also carry useful information. The heavens are not speaking in symbols, yet patterns in the air still reveal what may be on the way. Beauty and warning can arrive together in one bright circle. Full moonbeams cannot make their own light, only return the sun. It is easy to talk as though the moon shines, but that word can mislead. The moon is not a lamp or a star. It produces no visible light of its own. Everything you see on a bright lunar night is borrowed sunlight that has struck the moon and bounced onward toward Earth. That means moonbeams are second-hand brilliance. Their path begins at the sun, which is the dusty lunar surface, and only then continues to us. There is something wonderful in that chain. The light falling across a sleeping town has already touched another world. It has reflected off ancient rock and created plains before entering your eyes. This also explains why the moon changes phase. We see different portions of the sunlit half as the geometry shifts. The full phase is the moment when borrowed light is presented to us most completely. The moon seems self-possessed in the sky, yet its glow is an elegant act of dependence. Its beauty begins with the sun. The full moon is bright because rough dust reflects light back strongly. At first thought, you might expect a smoother surface to shine more brightly. On Earth, polished things often gleam best. The moon does something more interesting. Its ground is covered in fine broken material called regolith, made from eons of impacts that shattered rock into dust and fragments. That rough surface scatters sunlight in many directions, and near the full phase, it sends a surprising amount back toward the source direction, which happens to include us. The result is a strong jump in brightness when the geometry is just right. This means the moon's shine is linked to violence preserved over immense time. Every collision that helped grind the surface also helps shape the way it reflects light today. So, when the full disk glows with unusual strength, you are seeing the optical consequences of a battered world. The beauty is not despite the scars. In part, it is because of them. The moon shines the way it does because it has been broken for billions of years. Around full moon, the lunar surface suddenly surges in brightness. The change can be subtle to casual eyes, yet instruments measure it clearly. As the moon approaches the exact geometry of fullness, its brightness rises more sharply than a simple smooth trend would predict. In other words, the moon does not merely become steadily brighter night after night, and then reverse. It receives a final little boost near the full phase. That surprise is one reason planetary scientists pay close attention to how airless worlds reflect light. The effect reveals something about the texture and structure of the surface. It also helps explain why the full moon can feel startlingly intense compared with nights just before or after. Our nearest neighbor is not only well lit, it is responding to a special alignment in a way that makes it flash back more light than expected. This gives the full phase an extra layer of drama. The familiar bright disk is hiding a refined optical trick, one that turns a gradual cycle into a small crescendo right at the top. That brightness surge is called the opposition effect by planetary scientists. The name sounds technical, but the idea is elegant. It happens when the sun, the moon, and the observer line up so that the light is coming from almost directly behind the viewer. In that arrangement, tiny shadows cast by grains on the lunar surface become hidden from sight, which makes the ground appear brighter. There may also be an added boost from waves of light reinforcing one another when they scatter back along nearly the same path. Together, those effects help create the sudden jump in brightness near the full phase. Scientists study this not only for the moon, but for asteroids and other airless bodies as well, because it offers clues about surface texture and composition. So, a beautiful bright full moon is also a kind of laboratory result displayed in the sky. The glow that delights casual observers is carrying information. It tells us that even dust can have complex optical behavior, and that light itself can reveal the grain of distant worlds. The full moon reveals fewer deep shadows than a crescent moon does. A crescent moon can look dramatic through a telescope because the line between day and night cuts across mountains and crater walls, throwing long black shadows that carve the surface into sharp relief. By the time the disk turns full, much of that drama softens. Light pours down more directly, and many of those deep, dark pockets shrink or disappear from our view. To someone seeing the moon in detail for the first time, that can feel almost backwards. You might expect the brightest phase to reveal the most texture. Instead, it hides some of the strongest contrast. This teaches a beautiful lesson about seeing. Brightness alone is not enough to reveal shape. Shadows do much of that work. Remove them, and the land can seem calmer, broader, and less jagged. So, the full phase offers a different kind of beauty. It trades rugged drama for a wide-open face, and that face has fascinated humanity for ages. Craters look flatter at full moon because sunlight strikes them so directly. The moon is covered with bowls, basins, rims, terraces, and towering walls raised by ancient impacts. Yet, at the brightest phase, many of those features lose some of their apparent depth. The reason is simple and wonderfully visual. When sunlight arrives from nearly straight behind us, the floors and rims of craters are illuminated more evenly. So, the clues our eyes rely on become weaker. Without strong side shadows, the surface can seem smoother than it really is. It is a little like looking at footprints at noon instead of late afternoon. The shapes are still there, but their depth becomes harder to judge. This makes the full moon a subtle trickster. It presents the most complete face, yet it can disguise the violence that shaped it. The great scars of impact remain written across the surface, but the lighting softens their relief. A battered world suddenly seems more serene simply because the light has changed direction. Some lunar rays shine best during the full moon and nearly vanish otherwise. Across the moon run strange bright streaks that can stretch for hundreds of miles from certain craters, like frozen splashes thrown outward by colossal impacts. These are lunar rays, and they often become most striking when the moon is full. At other phases, they can fade into the general brightness and shadow of the terrain, making them harder to notice. But when light falls more directly and the contrast shifts, the rays can leap out with startling clarity. They look almost painted across the surface. What you are seeing is ejecta, material blasted outward when an impact smashed into the moon long ago and scattered brighter debris across the landscape. Some of these streak systems are vast enough to cross multiple regions. They give the moon a wild, explosive history that the smooth, round disk does not immediately suggest. On the right night, the full phase turns those ancient blast marks into one of the most spectacular patterns visible from Earth. Tycho's bright streaks become spectacular when the moon turns full. One of the most famous sights on the lunar surface begins at a crater called Tycho, a relatively young impact scar in the southern part of the near side. From it, pale rays shoot outward in all directions across the moon like spokes from a wheel or cracks in glass after a hard blow. During many phases, those streaks are less obvious, but near fullness, they can blaze into view with astonishing force. Suddenly, the moon looks less like a calm mountain and more like a record of catastrophe. Tycho itself was formed by a violent impact that hurled material across enormous distances, and the bright rays preserve that event as a visible signature. Through binoculars or a small telescope, this can be one of the most thrilling things to notice. A single collision left marks grand enough to be seen from Earth with modest equipment. The full moon gives that ancient explosion its best stage lighting, and the result can be unforgettable. The full moon helps certain impact scars blaze across the lunar face. Not every feature on the moon waits for the same lighting to become impressive. Some craters are at their most dramatic when shadows are long. Others announce themselves when the disk is full and bright ray systems begin to dominate the view. In those moments, the moon can look less like a landscape and more like an archive of impacts layered across deep time. Bright scars stand out against darker plains and older terrain, revealing where younger collisions blasted fresh material outward over the older surface. These marks can spread so widely that they seem almost too large to belong to one event. Yet, they do. A single strike can rearrange the appearance of a world. This is one reason the full phase matters to observers. It brings out evidence of violence written in brightness rather than in shadow. You are not just admiring a glowing ball. You are watching certain wounds of the moon flare into visibility, telling the story of blows it never healed from. People once thought the full moon's dark markings formed a human face. Once you notice the pattern, it can be hard to unsee. Two darker regions suggest eyes. Another patch becomes a nose or mouth. The bright and dark contrasts invite the mind to assemble features from shadowed shapes, and suddenly the moon seems to be looking back. This is not ignorance. It is a deeply human habit. Our brains are experts at finding faces, even when none were intended. We do it in clouds, in tree bark, in toasted bread, and in the arrangement of lunar planes. For many generations, that face in the moon became a familiar cultural image, repeated in stories, songs, illustrations, and nursery rhymes. It gave the moon personality and presence. A bright disk became a companion with expression. That response is fascinating because it sits at the meeting point of astronomy and psychology. The moon provides the pattern. The human brain provides the portrait. Together, they create one of the oldest imagined faces in the sky. Other cultures saw rabbits, a toad, or a tree in them. The dark markings on the moon have never belonged to just one interpretation. Around the world, different cultures looked at the same bright disk and discovered entirely different figures within it. In parts of Asia and the Americas, a rabbit became one of the most enduring lunar images. Elsewhere, people saw a toad, a woman, or a tree. These were not random guesses. They were shaped by local stories, beliefs, animals, and symbols that already mattered on Earth. The same moon became many things because human imagination is guided by culture as much as by vision. That is what makes these lunar figures so captivating. They show that the sky is shared, yet never seen in exactly the same way by everyone beneath it. The moon becomes a mirror for the mind. It offers the same markings to all observers, then lets each society draw meaning from them in its own language. One celestial face gave rise to many earthly stories. The full moon invited sky stories long before telescopes explained its scars. Long before anyone understood impact basins, lava plains, or orbital mechanics, the bright round moon was already one of humanity's great storytelling prompts. It was too striking to ignore and too patent to seem empty. People wanted to know what it was, who lived there, why it changed, and what it meant for life below. So, stories grew around it. Some explained the dark markings as figures placed in the sky. Some treated the moon as a deity, a timekeeper, or a witness to human affairs. Others tied it to hunting, planting, fertility, or fate. These stories were not failures of thought. They were early attempts to weave the sky into human meaning. The full phase especially invited that response because it was so visible, so memorable, and so easy to share across generations. Even after science began explaining the moon in physical terms, the storytelling instinct never disappeared. Knowledge changed the details, but wonder kept speaking. Many names for full moons come from seasonal rhythms on Earth. People did not name bright moons just to be poetic. In many traditions, those names helped connect the sky to recurring events on the ground. A full moon near harvest time mattered because crops were ready. A moon linked to winter cold, spawning fish, falling leaves, or flowering plants mattered because those changes shaped work, travel, food, and ritual. The names acted like memory hooks that tied celestial cycles to the turning year. They also reveal something important about human attention. For most of history, people watched both sky and land closely because survival depended on noticing patterns. The moon became part of that larger system of seasonal awareness. A named full moon was not merely a spectacle overhead. It was a signpost within the calendar of lived experience. Even now, those names endure because they make the night feel connected to the world beneath it. The moon is still above us, but its meanings were often born from rivers, forests, fields, weather, and the labor of ordinary lives. The harvest moon is the full moon nearest the autumn equinox. That title sounds ancient because it is rooted in a real seasonal need. As summer ends and autumn begins, fields reach one of the busiest moments of the year. Grain must be gathered, fruit must be brought in, and weather can turn quickly. The full moon closest to the autumn equinox earns special attention because it arrived during that urgent stretch of labor. People noticed it not merely as a lovely object in the sky, but as part of the rhythm of survival. It belonged to the season of reaping. That connection gave it a name strong enough to endure into the modern age. Even for people far removed from farming, the phrase still carries weight. It ties one bright moon to a particular hinge of the year, when daylight is shrinking and the landscape is changing character. The sky and the land briefly seem to speak the same language, and the full moon becomes part of autumn's turning story. A harvest moon can rise with unusually little delay on successive evenings. Most people learn that moonrise shifts later each day, and that is true. Yet around the harvest moon, something more subtle happens. Near that season, the moon's path meets the horizon at a shallower angle for many northern observers, so the usual delay between one moonrise and the next becomes smaller than expected. Instead of arriving much later each evening, it can seem to return at nearly the same hour for several nights in a row. That creates a remarkable effect. The bright moon appears to keep close company with dusk, just when extra evening light would have been most welcome. This is one of those astronomical details that feels almost designed for human life. Though it is simply geometry and timing, still, the effect can seem generous. The sky behaves a little differently at just the right moment in the year. The harvest moon is not only named for the season, it also performs in a way that suits it. That brief pattern once gave farmers extra light during harvest time. Before electric lamps spread across the countryside, even modest changes in evening light could matter. Fields did not harvest themselves, and autumn brought pressure. Crops had to be gathered before storms, rot, or early frost could undo months of work. Around the harvest moon, the reduced delay in moonrise meant bright nights arrived in useful succession. Extending the working hours at a critical moment, People could see enough to continue bridging in grain, stacking sheaves, loading wagons, or moving through fields after sunset. This did not turn night into day, yet it could make a practical difference. That is part of why the harvest moon became more than a pretty seasonal phrase. It was remembered because it helped. The full moon became a partner to later, not just a spectator above it. There is something moving in that idea, a celestial cycle, indifferent in itself, still aligned with human effort closely enough to earn gratitude, notice, and a lasting place in tradition. The hunter's moon follows the harvest moon in the old naming tradition. Once the harvest was largely complete, another seasonal phase came into focus. Fields have been cleared, leaves were thinning, and animals could sometimes be spotted more easily across more open ground. The full moon that followed the harvest moon came to be known in many traditions as the hunter's moon, linking it to autumn when food gathering shifted in emphasis, whether through hunting, storing meat, or preparing for the harsher stretch ahead. People read the season in the sky and named it accordingly. What is fascinating is how practical these names were. They were not random ornaments at Aceto the moon. They reflected the changing year of work, weather, and survival. The hunter's moon carries that sense of transition. Autumn is deepening. The abundance of harvest is giving way to preparation and pursuit. A bright disk overhead becomes a marker that the season has moved on and that human attention must move with it. A blue moon is usually the second full moon in 1 month. That modern definition became famous cause it is easy to remember and because it captures a real calendar oddity. The moon cycle does not fit neatly inside our months. So, from time to time, 1 month manages to contain 2 full moons instead of 1. When that happens, the second is commonly called a blue moon. It does not usually look blue at all. The name is about timing, not color. Part of the charm lies in the surprise. Full moons feel regular and familiar, yet now and then, the calendar slips just enough to produce an extra 1. It is a reminder that our month names and page layouts are human systems placed over older celestial rhythms that do not obey them perfectly. That mismatch creates the rarity. A blue moon is special not because the moon behaves strangely, but because our calendar briefly reveals that it was never fully in charge. The sky keeps its own schedule, and sometimes it shows. Sometimes blue moon means a rare seasonal full moon instead. Before the popular month-based definition spread widely, there was another meaning that still matters. In that older usage, a blue moon referred to an extra full moon within a season that already contained the Uzawa number, making it the third of 4 full moons in that seasonal span. This may sound a little more complicated, but it grew from calendar keeping that paid close attention to the relationship between lunar phases and the turning year. The phrase reminds us that names can carry layered histories. One expression, two legitimate traditions. That alone is fascinating because it shows how skywatching is not only about astronomy, it is also about culture, memory, and the ways people choose to organize repeating events. The blue moon became famous as a symbol of rarity, and both meanings support that feeling. In either case, the moon itself has not turned strange or changed color. What changes is the framework we use to count it, and that framework occasionally produces a rare extra appearance. A supermoon is a full moon that happens near lunar perigee. The moon does not travel around Earth in a perfect circle. Its orbit is slightly stretched, which means there are times when it comes closer to us, and times when it drifts farther away. The closest part of that orbit is Calid perigee. When a full moon occurs near that point, people often call it a supermoon. The term sounds dramatic, and in a way, it is deserved. The moon is genuinely nearer than usual, so it appears somewhat larger and brighter than a more distant full moon. What makes this captivating is the combination of familiarity and motion. The moon looks so constant that many people never suspect it is creeping closer and farther over time. Yet it is. The full phase near perigee lets that orbital variation become visible to ordinary observers. A world that already dominates the sky can suddenly feel a little more present, a little more forceful, and a little more difficult to ignore. A supermoon looks bigger, though the difference is subtler than many expect. Pictures and headlines can make it sound as though a supermoon will fill half the sky, but the real difference is more restrained. Compared with the more distant full moon, the increase in apparent size is noticeable, especially in careful side-by-side comparisons or for experienced seers. Yet it is not usually overwhelming to the casual eye. This is important because the true fascination lies in the reality, not the exaggeration. The moon does not need to become gigantic to be interesting. What matters is that its changing distance can be seen at all from Earth with any advanced equipment. That is extraordinary. A subtle shift in orbit becomes a visible effect in the sky. The supermoon is therefore a lesson in humility. It rewards looking closely instead of expecting spectacle alone. Many of the sky's best wonders are like this. They are not crude or theatrical. They are delicate signs that the universe is moving with more nuance than first impressions suggest. A micromoon is a full moon that happens near lunar apogee. If a supermoon is the full phase, Earth moon's closest approach, a micromoon is the opposite case. It happens when the full moon occurs near apogee, the farthest part of the moon's orbit. The result is a full disk that appears a little smaller and dimmer than one near perigee. It still looks magnificent, of course. The moon remains the commanding light of night. Yet this more distant version reveals something elegant about celestial mechanics. The same familiar full phase can arrive under slightly different conditions because the orbit is always carrying the moon through a changing relationship with Earth. The micromoon is a reminder that nodal full moons are equal in distance, even when they feel equal in meaning. It adds depth to the idea of lunar repetition. The cycle repeats, but never as a perfect copy. Each return carries small variations, and sometimes those variations place the moon at the far edge of its monthly wandering. Even a distant full moon still dominates the sky with ease. This may be the most telling thing about full moon's power. Even when it is near apogee and appears somewhat smaller than average, it still overwhelms the night in a way almost nothing else can. Stars fade. Landscapes brighten. People stop and look up. The moon does not need to be at its nearest to command attention. Its basic presence is already enormous in human experience. That fact helps keep orbital variations in perspective. Yes, some full moons are closer and some farther. Size and brightness change slightly, but the deeper truth is that our nearest celestial neighbor remains visually and emotionally dominant across all those differences. A micromoon is not a lesser wonder. It is proof of how strong the moonshade on us already is. Even at the far end of its orbit, a nearless world of rock and dust can still take possession of the sky and the imagination. Distance changes. The spell remains. The full moon can appear huge in photographs only with clever lenses. When people see those famous images of an enormous full moon looming behind a city skyline or balanced beside a distant tower, they often imagine the moon itself swelled to impossible size. What actually changed was the photography. A long lens compresses distance and makes for objects seem stacked closer together than they look to human eyes. The moon stays the same. The building stays the same. Yet the camera rearranges their apparent relationships and turns an ordinary moonrise into something dramatic and not seem unreal. That is why those images feel so thrilling. They reveal not a giant moon, but a giant difference between perception and technique. Photographers often scout locations with remarkable care, waiting for the exact alignment of moon, landscape, and viewpoint. It can take planning, patience, and luck. So, those breathtaking images are not fake in the simple sense. They are real scenes, shaped by optics, geometry, and timing, which makes them a fascinating art form all their own. Your camera and your eyes do not judge moonlit the same way. Human vision is wonderfully adaptive. When you stand beneath a bright full moon, your eyes adjust to darkness and build a richer experience from limited light. The landscape can feel luminous, spacious, and full of detail. The camera does not experience the scene that way. It records according to exposure restings, sensor limits, and a particular balance between bright and dark parts of the view. That is why moonlit scenes often disappoint beginners. The moon itself may turn into a white, featureless blob, while the foreground sinks into blackness. Or the land may appear well exposed while the moon becomes blown out and unnatural. The camera is not wrong, and neither are your eyes. They are simply different systems for gathering light and making sense off-world. This difference is part of what makes moon photography so interesting. It forces people to realize that seeing is not a single process. The night sky changes depending on the instrument, and your own eyes are among the most remarkable instruments you own. Exposure for a full moon is closer to daylight than people expect. Many beginners assume that because the moon hangs in a dark sky, it must require long night exposures. That idea makes sense at first, but it leads straight to disappointment. The moon itself is in direct sunlight, and that matters far more than the darkness around it. If you expose as though the moon were a dim night object, the bright lunar surface quickly turns into a washed-out patch with little or no visible detail. The surprise is useful because it teaches an important rule of observation. The subject illumination matters more than the surrounding mood. A full moon looks serene in a dark sky, yet its face is lit much more like a sunlit landscape than a typical night scene. This is one reason moon photography can feel counterintuitive. The emotional setting says night, but the exposure logic says something closer to day. Once people grasp that contrast, the moon becomes not just easier to photograph, but far more fascinating to think about. The full moon is bright enough to fool beginners into overexposure. This is one of the classic mistakes in moon photography. A person raises a camera, sees darkness everywhere except that glowing disk, and assumes the moon needs shelp. So they lengthen the exposure or raise its sensitivity too far. The result is often disappointing. The delicate tones vanish, crater detail disappears, and the moon turns into a flat white coin with no character at all. That failure is instructive because it reveals how deceptive brightness can be in context. Against a dark sky, the moon feels like a soft lantern. To a camera sensor, it can be a harsh, bright target. Learning to photograph it well means learning to distrust first impressions, and to treat the moon as a brilliant sunlit object rather than a dim ornament of the night. In that sense, the camera becomes teacher. It shows that the full phase is not merely pretty, it is optically demanding. The moon is bright enough to punish assumptions, which makes success feel especially satisfying. Full moon photography often reveals detail invisible to casual stargazers. A camera with steady support, carry flexpery, and a decent lens can gather the moon in ways the naked eye usually cannot. Bright ray systems become more obvious. Borderlines between dark planes and brighter highlands sharpen. Subtle tonal differences across the face emerge, and the surface begins to look less like a simple glowing disk, and more like aerial place with distinct regions and history. This is one reason photographing the full moon can be so rewarding. It turns a familiar sight into an invitation to study. You may have looked up at the moon countless times, yet the photograph shows you patterns you never noticed before. The image lingers, allowing attention to deepen beyond the fleeting glance. In that way, photography can act like a patient second look. It does not replace wonder, it extends it. The moon becomes richer the longer it is examined, and a good image lets the eye keep exploring a world that otherwise might have passed as only a bright circle in the sky. During a lunar eclipse, the full moon can turn copper or blood red. Few sights in the sky feel more dramatic than watching a familiar bright moon lose its silver light and darken in toward The transformation can seem almost supernatural, which helps explain why eclipses have stirred fear, ritual, and awe throughout history. Yet, the cause is beautifully physical. As the moon moves into Earth's shadow, direct sunlight no longer reaches it. If the alignment is deep enough, the moon should vanish into darkness. Instead, some light bends through Earth's atmosphere and spills into the shadow. Along the way, bluer tones are scattered out, and redder light survives more effectively. That filtered glow then reaches the moon and paints it in shades of copper, rust, or deep blood red. So, an eclipse does not extinguish the moon completely. It changes the kind of light that fins it. A bright companion becomes a dim ember of light, and for an hour or two, the moon looks like a different world entirely. A red eclipsed full moon is lit by every sunrise on Earth. This may be one of the most astonishing ways to think about a lunar eclipse. When the moon sits inside Earth's darkest shadow, it is not shining by direct sunlight. Instead, the light reaching it has been bent through a ring of Earth's atmosphere all around the planet. From the moon's point of view, every sunrise and sunset on Earth is happening at once along the edge of our planet. That reddish light is gathered, filtered, and redirected into the shadow, where it softly illuminates the lunar surface. In a sense, the eclipsed moon glows with combined color of Earth's atmosphere. This idea gives the event extraordinary. You are not merely watching the moon darken. You are seeing our planet participate in the image. Earth is no longer just the place you stand. It becomes an optical actor in space, casting a shadow and tinting the light within it. The eclipse becomes a portrait of the Earth-Moon system working together. Lunar eclipses can only happen when the moon is full. That rule follows from pure geometry. For Earth to cast its shadow onto the moon has to be on the far side of Earth from the sun. That is exactly the arrangement of the full phase. A crescent or half moon is simply in the wrong place for such an event. This is one reason lunar eclipses feel so satisfying to understand. The spectacular red moon is not random. It is the natural consequence of alignment. Sun, Earth, and moon must line up in nearly a straight line with Earth in the middle. When they do, the familiar full disk enters shadow, and the show begins. That connection makes eclipses a perfect example of how astronomy turns drama into clarity without reducing wonder. The explanation does not flatten the event. It deepens it. The next time a full moon rises, you can know that every lunar eclipse begins with something outwardly ordinary. The extraordinary part comes when the alignment sharpens and Earth's shadow finds its target. The full moon can brighten a landscape enough to cast clear shadows. That fact startles people who have mostly seen it from cities, where streetlights overwhelm the effect. Step into a dark, rural place at the right time, and the change can feel almost magical. Fences draw lines across the ground. Tree, branches, sketch patterns. Your own shadow can follow beside you, pale and strangely soft. This is not a trick of imagination. The light is genuinely strong enough to copy the land into contrast. Explorers, farmers, sailors, and night travelers since depended on that difference. A bright moonlit night was not merely beautiful, it was useful. It changed when people could move, work, and find their way. There was also something deeply unsettling and fascinating about shadows made by moonlight. They resemble daytime shadows, yet the world remains hushed and blue with night. Familiar places seem both known and transformed. That strange mixture is part of the full moon's power. It lets the dark keep its mystery, while borrowing just enough light to redraw the world. Most full moons miss Earth's shadow and shine on untouched. If full moon and eclipse are so closely related, why do eclipses not happen every month? The answer lies in the moon's orbit, which is tilted relative to Earth's path around the sun. Most months, the full moon passes a little above or below the line where perfect alignment would place it in shadow. The result is an ordinary bright full moon instead of an eclipse. This is a wonderful reminder that celestial events depend on precision. Broad arrangement is not enough. The geometry must be exact enough for shadow to fall in the right place. Because that usually does not happen, most full moons remain clear of Earth. Stars and sand continue shining without interruption. That ordinary outcome is easy to overlook, because eclipses are so dramatic. Yet, it is the mist shadow that makes eclipses special. The rare dramatic event depends on many quiet months when the moon glides past unharmed, bright, and complete, while Earth's shadow slips by unnoticed through space. Some full moons glide through penumbral shadow so gently few notice. Not every eclipse announces itself with a red moon or a dramatic bite taken from disk. Sometimes the moon passes only through Earth's penumbra, the outer and softer part of the shadow. In that case, the change can be subtle enough that casual observers miss it entirely. The moon may look only slightly dimmer in one side, as though a faint veil had been drawn across it. There is something fascinating about that restraint. We often imagine celestial events as obvious spectacles, but the sky also offers delicate performances that reward cruel attention. A penumbral eclipse is one of those. It tasks the observer to notice not transformation, but nuance. The familiar full moon remains almost itself, yet not quite. That slight difference can be strangely compelling once you know what you are looking for. It reminds us that shadow in space has layers, and that even an event most people barely register is still the result of one world drifting through the edge of another world's darkness. The full moon can reveal how tilted the moon's orbit really is. At first glance, the moon seems to follow a simple path around Earth, but its orbit is slightly tilted compared with Earth's path around the sun. That small tilt is easy to ignore until you think about eclipses. A full moon means the moon is on the far side of Earth from the sun, which sounds like perfect shadow territory. Yet, most months nothing dramatic happens. The bright disk sails past, without entering Earth's shadow at all. That quiet miss is the clue. It tells us the moon is usually traveling a little above or below the exact line needed for an eclipse. In other words, the ordinary full moon is evidence of a tilted orbit. You can almost read the slant from the absence of spectacle. That is one of the loveliest things in summertimes. The sky reveals its structure not through rare fireworks, but through the repeated calm of what does not happen when you think it should. Without that orbital tilt, every full moon would bring an eclipse. Imagine a sky where each full moon darkened and reddened every single month. That would be normal if the moon orbited in exactly the same plane as Earth's journey around the sun. In that perfectly aligned arrangement, Earth would stand directly between sun and moon each time the moon turned full, and its shadow would sweep across the lunar face without fail. The fact that this does not happen is one of the most important clues to how the system is arranged. A small tilt is all it takes to spare most full moons from eclipse. That tiny angle changes everything. It turns a monthly certainty into an occasional event, and rarity gives eclipses much of their power. They are not routine machinery. They are special moments when the moving parts line up closely enough for a shadow to strike. So, the next ordinary full moon carries an invisible lesson. It is bright because the geometry is just slightly off, and that slightness is enough to preserve the night's familiar light. The moon's orbit is not a perfect circle, so each full moon differs. It is tempting to imagine the moon moving around Earth on a neat, uniform track, as if drawn with the compass. In reality, the orbit is slightly oval. That means the moon is sometimes nearer and sometimes farther from Earth as it makes its monthly journey. The full phase can happen at any point along that changing path, which gives one full moon a slight different distance, apparent size, and brightness from another. These changes are not usually dramatic enough to shout for attention, yet they are real, measurable, and surprisingly meaningful. They remind us that repetition in Thesky is rarely exact. Repetition. The moon returns in phases, but not as a perfect copy of itself. There is variation folded into Thesical. That makes the full moon more interesting than a simple clock hand. It is a recurring event carried by apeth with nuance, stretch, and asymmetry. The sky repeats its patterns, but it does not print them from a single mold. The full moon can arrive within hours au perigee or very far from it. Perigee is the point where the moon comes closest to Earth in its orbit, and the full phase is a separate time ingenterly, set by the moon's position relative to the sun. Sometimes those two rhythms happen to meet closely. Sometimes they are far apart. This means one full moon may arrive when the moon is near its closest approach, while another may occur when it is nowhere near that part of the orbit. That shifting relationship is a wonderful example of how different celestial cycles overlap. The moon is not following one single schedule. It is following several at once, and their combinations keep producing new variations. This is why some full moons earn extra tension, while others pass more quietly, even though the phase itself is the same. The timing underneath has changed. The bright, round moon becomes a moving intersection of orbital patterns, and its character depends on how those patterns line up. In that particular Earth and Moon both orbit a shared balance point in space. Many people picture the moon circling a perfectly still Earth, but that is not quite right. Earth and moon both move around a common center of mass, a balance point created by their mutual gravity. Because Earth is much more massive, that point lies inside our planet, though not at its exact center. Even so, the important truth remains. The moon does not simply dance around Earth while Earth stands motionless like a pillar. Both bodies are in motion together. This gives the Earth-Moon system a subtler kind of elegance. The larger world still yields just slightly to the smaller one. That shared motion is not something you can see by glancing up at a full moon. Yet it is part of the reality behind every lunar rise and set. The moon is not merely a captive companion. It is a partner in a gravitationalization. And even our planet must shift its stance in response to that of an at full moon. Earth's pull and the moon's pull shape each other. The bright round face in the sky can seem calm and detached, but gravity is binding Earth and moon into a constant physical conversation. Earth's gravity keeps the moon in orbit, while the moon's gravity acts back on Earth, tugging at oceans and even very slightly affecting the solid body of the planet. The moon is not strong enough to dominate Earth, yet it is strong enough to matter deeply. The relationship goes both ways. Earth has helped lock the moon into the same phase toward us, and the moon in turn raises tides and contributes to long, slow changes in Earth's rotation. This means the full phase is not Morellian image. It is one moment within an ongoing exchange of force. The beauty overhead is supported by invisible tension between two worlds that have been shaping one another through immense stretches of time. When you look at the full moon, you are not seeing an isolated object. You are seeing one half of a gravitational partnership. The full moon helps slow Earth's spin by releasing tidal bulges. The moon's gravity pulls on Earth and Even Lebekis, the side closer to the moon feels a slightly stronger tug than the side farther away. This difference helps create tidal bulges in Earth's oceans. As Earth spins, those bulges do not line up perfectly with the moon. Because of friction and motion complicate the picture. They are dragged a little ahead. That offset matters. The bulges pull back on the moon and the moon pulls on them, creating a transfer of energy and angular momentum that gradually slows Earth's rotation. The change is tiny across a human lifetime, yet over immense spans, it adds up. Days in the distant past were shorter than they are now. Thesis astonishing Bekis, it means the full moon is connected in a long, slow way to the length of the day itself. A bright disk rising over the horizon is part of a process that has been gently breaking our spinning planet for ages. That same tidal dance slowly pushes the moon farther away. The slowing of Earth's rotation is only half the story. As tidal forces drain a little rotational energy from Earth, some of that energy is transferred into the moon's orbit. The result is that the moon gradually moves outward, inching farther from use of her time. This is not guesswork. Scientists can measure the recession with remarkable precision using reflectors left on the moon by astronauts. Laser pulses sent from Earth bounce back, allowing the distance to retract with exquisite care. That means the full moon we see tonight is not quite where it would have been in the distant past. The change is tiny from year to year, but relentless across millions of years. Our nearest celestial companion is slowly drifting away. There is something poignant in Thetydia. The moon that shapes our tides, stories, and nights is not fixed in place forever. It is part of an evolving system, and the distance between our worlds is still being rewritten. Ancient full moons were larger because the moon orbited closer to Earth. Go back far enough in time, and the moon would have looked more imposing in Thesky than it does today. Because tidal interactions have been pushing it outward over vast stretches of history, the earlier moon orbited at a smaller distance. A closer moon would have appeared larger and brighter, and its gravitational effects on Earth would have been stronger as well. Imagine ancient shorelines and the more powerful tide sand, a full moon that claimed even more of the sky. That is not fantasy. It is the natural consequence of an evolving orbit. The moon we know now is only the current version of a long relationship. This fact adds a thrilling dimension to deep time. The night sky itself had a different scale in Earth's earlier ages. When we picture the distant past, we often think of different continents, climates, or creatures. We rarely remember that the moon overhead was different too, larger in appearance and closer in presence than the one we see now. Dinosaurs once saw slightly bigger full moons than we do today. That simple thought can make deep time feel unexpectedly personal. Dinosaurs walked under moonlight too. They saw the same phases, the same bright, round lunar face, and the same rising disk above ancient horizons. Yet the moon above their world was a little closer than it is now, which means it would have appeared slightly larger in the sky. The difference was not monstrous from one generation to the next, but across tens of millions of years, it became surreal. This is one of those facts that joins ordinary experience to prehistoric scaling a single image. A creature standing beside a fern forest and looking up at a full moon was hearing something with us, but not exactly the same thing. The sky had shifted. That idea is powerful because it makes the moon part of Earth's living history. It was present for worlds long gone, and even while seeming constant, it was already changing slowly enough to escape notice, and surely enough to matter. The full moon can disturb darkness enough to change animal behavior. Night is not one thing in nature. It can be black and concealing, or bright enough to reshape the choices animals make. When the moon turns full, that change in brightness spreads acres forests, shorelines, grasslands, and open water. Creatures that rely on darkness for cover may move less, feed differently, or stay hidden longer. Others may use the extra light to travel farther, spot rivals, or locate mates. In that sense, the full moon does not merely illuminate the landscape. It rewrites the rules of the night for a little while. Biologists sometimes call this the lunar landscape of fear or opportunity, depending on the animal involved. What matters is that moonlight becomes an ecological force. A bright sky can alter risk, timing, and behavior without making a sound. The full moon is therefore not just a spectacle for humans. It is part of the lived environment of countless species, quietly changing what dark allows. Some coral species time mass spawning with the full moon. On certain nights in warm seas, the ocean can stage one of the most extraordinary coordinated events. Uncorals that spent much of the year growing in silence release eggs and sperm into the water in near unison, turning the sea into a drifting cloud of future life. In some species, this timing is linked to the lunar cycle, with the full moon helping provide a reliable cue in combination with season, temperature, and day length. The precision is astonishing, because the corals have no brains, in the usual sense. No eyes watching the sky as wedo, yet entire reefs can respond to celestial timing with breathtaking coordination. This matters because successful reproduction depends on many individuals releasing their gametes together. The moon becomes part of the choreography of a reef. What looks like a quiet underwater city is actually keeping time with the sky. A bright phase overhead can help trigger one of the most important and beautiful reproductive events in the sea. Grunion fish race ashore around high tides near full and new moon. Along parts of the Pacific coast, certain small silver fish perform a ritual so strange it feels almost invented. During a few nights after the highest tides linked to full and new phases, grunion ride the surf onto sandy beaches. The females wiggle tail first into thuet sand and lay eggs above the reach of ordinary waves, while males curve around them to release sperm. Then the adults return to the sea, leaving the buried eggs behind. Days later, when especially high tides return, the surf frees the young and carries them into the ocean. This is lunar timing made visible in one of the most dramatic ways imaginable. The moon is not only bright in the sky. Through tides, it helps set the schedule for a fish to leave the water and reproduce on land's edge. That is the kind of full moon story that overturns expectations. A celestial cycle becomes a beachside survival strategy written in motion. Predators often hunt differently when full moon brightens the landscape. A brighter night changes the balance between hunter and hunted. For some predators, more light can be useful. An owl may spot movement more easily across open ground. A mammal that hunts by sight may cover territory with greater confidence. Shorebirds, foxes, reef hunters, and many other animals can experience the night differently when the landscape is no longer wrapped in deep darkness. Yet, the advantage is not always simple. A bright sky can also expose the predator itself, making stealth harder and reducing surprise. That is why scientists often find no tone universal rule, but a shifting pattern shaped by habitat, species, and hunting style. The fascinating part is that the full moon becomes a variable in the strategy of survival. A predator is not entering the same night every evening. It is entering a version of the world whose visibility has changed. One increase in light can ripple through movement, timing, risk, and success in the lives of hunters across ecosystems. Some prey animals become more cautious in bright full moon nights. For animals that depend on darkness as protection, moonlight can feel dangerous. A rodent crossing open ground under a bright sky may pause longer, hug cover more closely, or avoid foraging altogether. Small mammals, birds, reptiles, and even some marine creatures can reduce activity when they are easier to spot. The effect is not simply fear in a human, it is a pattern shaped by natural selection, where individuals that behaved more cautiously under bright conditions may have been more likely to survive. This means the full moon can influence not just what predators do, but what prey decide not to do. Food may be left uneaten, journeys may be delayed, mating calls may be reduced. The night's brightness changes the pressure of exposure. What makes this so compelling is how quiet the mechanism is. The moon does not command these animals. It alters visibility, and visibility alters behavior. A bright disk overhead becomes part of survival mathematics of the dark. Nocturnal insects can lose their way under intense moonlight and artificial lights. Many night-flying insects navigate using light cues from the sky, and that system evolved in a world where natural sources were distant and predictable. The moon, though bright, holds a stable position relative to a short flight, which can help with orientation. Modern artificial lights create a different problem. They are nearby, overwhelming, and confusing. Insects that try to use them as a reference can spiral, circle, or become trapped in aimless motion. On bright moonlit nights, the situation can grow more complex because natural and artificial cues may compete in a changed sky. Some insects may reduce activity under brighter conditions, while others may be drawn into visual confusion that wastes energy and increases danger. This is one of the more haunting consequences of electric light. We did not simply brighten the night for ourselves. We altered the navigation environment for creatures that evolved with lunar and stellar patterns. The full moon belongs to an ancient system. Streetlights do not. Sea turtles use natural light cues that full moon nights can complicate. When sea turtles emerge from nests, the hatchlings face one of the most urgent journeys in nature. They must find the ocean quickly. On natural beaches, the brighter open horizon over the water can help guide them, while the darker landward side offers a contrast. Moonlight can become part of that visual world, reflecting on the sea and changing the brightness pattern they respond to. Under natural conditions, this may still lead them the right way. But where coastal lighting intrudes, the situation becomes far more difficult. Bright artificial lights from hotels, roads, or homes can compete with or overwhelm the cues. Hatchlings evolve towels. The result can be tragic disorientation, with young turtles crawling inland instead of toward the surf. The full moon sits at an important crossroads here. It is part of the natural night system that shaped turtle behavior. Yet human lighting can scramble the transient guidance. A delicate life and death journey becomes confused at the very first step. Some desert creatures wait for darker nights instead of full moon brightness. Deserts may seem empty in daylight, but many of their inhabitants come alive for these animals. Darkness is a shelter from heat and from sharp-eyed predators. When the full moon brightens, open sand and sparse ground cover, that shelter thins. Some rodents reduce their movement. Certain insects remain hidden longer. Small creatures that would normally cross exposed ground may postpone thassa trips until the sky grows darker again. In environments where cover is limited, moonlight can make every shadow matter. This is one reason lunar cycles can shape activity so strongly in deserts. A bright night is not merely a visual, it can alter feeding schedules, mating opportunities, and the route an animalis willing to risk. The desert teaches this especially because the landscape leaves so little room to hide. The full moon turns wide open ground into an illuminated stage, and not every creature wants to perform beneath the man's sleep can shift subtly around the full moon in some studies. The idea that the moon affects human sleep has fascinated people for ages, and modern research has produced interesting, though not always consistent, hints. In some studies, participants took a little longer to fall asleep, slept slightly less, or showed small changes in sleep patterns around the full phase. These effects are usually modest rather than dramatic, and they do not occur with the same strength in every study. A reverie person. That uncertainty is part of what makes the subject interesting. Human sleep is influenced by many things, including light exposure, routine, stress, and expectation. The moon may be one subtle factor among many, or its apparent effects may vary depending on context. Either way, the question remains captivating because it touches something for most of human history, nights were darker and more directly shaped by lunar light. The possibility that our sleep still carries a faint echo of that world is difficult to dismiss completely. The strongest claims about full moon madness remain scientifically unproven. Stories about strange wild crowds, emergency room chaos, and sudden human irrationality under a full moon are deeply rooted in culture. The moon has long been treated as a trigger for unrest, which is why words like lunacy carry lunar echoes. Yet, when scientists have looked carefully for consistent evidence of dramatic spikes in crime, illness, accidents, or psychiatric disturbance leading to the full phase, the strongest claims have generally not held up. That does not make the myth foolish. It makes it revealing. The full moon is bright, memorable, and emotionally charged. So, unusual events that happen under it are easier to notice. And remember, quiet, ordinary nights are forgotten. A striking night with a bright moon, and a strange story sticks in the mind. This is a classic recipe for belief. The lesson is not that the moon isn't interesting. Quite the opposite. It is so powerful in imagination that people have often given it more control over human behavior than the evidence it can support. Hospitals do not reliably become wilder just because the moon is full. It is a stubborn modern legend that emergency rooms erupt into chaos whenever the moon turns full. Nurses hear it. Doctors joke about it. Patients repeat it. The story survives because it feels plausible. A bright moon already carries centuries of folklore, and hospitals are places where unusual nights are remembered intensely. Yet, when researchers have examined records and looked for dependable jumps in admissions, injuries, births, psychiatric crises, or other hospital activity linked specifically to the full phase, the evidence has usually failed to show a consistent pattern. That does not mean busy nights never happen under a full moon. Of course, they do. The point is that they also happen under every other kind of moon. What makes the legend powerful is memory. A hectic shift under bright moonlight feels meaningful and easy to recall. An equally hectic shift under cloud or darkness does not leave the same mark. The moon becomes the story because the story is easy to love. The full moon makes dark countryside look strangely familiar at night. Places that vanish into mystery on moonless evenings can suddenly return with enough detail to feel almost known again. A lane through fields, a hedgerow, a barn roof, a line of distant trees, all can reappear in pale outline. Yet, the recognition is never complete. That is what makes the experience so uncanny. The world seems recovered, but not restored. Shapes are clear, while colors are nearly gone. Distances can feel misleading. Open ground may look flatter than it is. Water may gleam where there is only frost. Under bright moonlight, the countryside becomes a version of itself, one translated into silver, charcoal, and soft contrast. For people before electric grids, that version of the land must have been deeply familiar. It expanded the useful hours of the night and changed what darkness meant. Stepping into that kind of landscape can feel like entering an older world. The roads are still ours, but the light belongs to a much earlier age. Many lunar myths survive because bright nights feel emotionally different. A bright full moon does more than light. It changes mood. Familiar places look altered, yet still recognizable. Distances feel uncertain, shadows remain, but they are no longer complete. The night seems both safer and stranger at once. That emotional shift matters because human beings have always made meaning from atmosphere as well as facts. A moonlit night can feel charged before anything unusual happens at all. Once that feeling exists, stories gather around it naturally. The moon becomes a stage for omens, transformations, secret journeys, and restless thoughts. Myths endure because they are attached to a real experience, not because the stories themselves are scientifically true. The experience is that the world under bright moonlight feels changed. Even now, with streetlights and screens around us, a clear full moon can still make people pause and feel that the night has become something special. Myth survives where emotion keeps finding a place to live. The full moon has inspired poets, priests, sailors, and scientists alike. Few objects in the sky have spoken to so many kinds of minds at once. Poets found river, loneliness, romance, and memory in its light. Priests and ritual leaders tied it to sacred calendars, ceremonies, and signs of cosmic order. Sailors watched it with practical respect because moonlight changed the sea and the work of the night. Scientists turned telescopes toward it and discovered a world of basins, mountains, lava plains, and impact scars. What is remarkable is that none of these responses cancel the others. The same full moon can be beautiful, useful, sacred, and measurable all at once. That is part of its enduring power. It resists being reduced to one category of human thought. You can calculate its orbit and still feel awe. You can understand its geology and still write a song about it. Across centuries, the full moon has remained one of the rare things that invites emotion, observation, and reverence to stand together in the same place. Ancient temples and monuments may have tracked full moon extremes. Some ancient structures appear to have been placed or aligned with extraordinary care, and in a number of cases, researchers have wondered whether certain sites were built to mark not only the sun's motions, but also rare lunar positions. The moon does not always rise and set in the same places along the horizon. Over a long cycle, those extremes shift, reaching especially far points that can be striking to track. Certain monuments and stone arrangements may have been designed with those far northern or southern moonrises and moonsets in mind. The evidence is stronger at some sites than others, and interpretation requires caution. Yet, the possibility is thrilling. It suggests ancient observers were patient enough to follow a pattern that unfolds over many years, not just over a month or a season. If true, these places were not merely built under the sun, they were built in conversation with it. Stone, memory, and moonlight may have been part of the same long act of observation. Full moonlight is far dimmer than daylight, but far brighter than starlight. It occupies a strange middle world that changes the night without truly erasing it. Under the sun, colors blaze and detail leaps forward. Under stars alone, the land can dissolve into suggestion and outline. Under a bright moon, the world becomes readable again, though in a quieter register. You can follow a path. You can pick out hills in the distance. Water can shine like metal, yet much remains softened, drained of color, and wrapped in shadow. That in-between quality may be one reason moonlit nights feel so memorable. They are not ordinary darkness, and they are certainly not day. They create a third condition, one our ancestors knew intimately. Painters, writers, and composers have long been drawn to that threshold where things are visible but transformed. Science can describe the brightness difference, but the experience is what stays with people. The moon does not overpower the night. It negotiates with it, and the result feels almost otherworldly. The full moon can wash out faint stars across the entire sky. On bright nights, the heavens lose some of their depth. The stronger moonlight brightens the background of the sky, and stars that would normally prick through the darkness fade from view. Constellations can become harder to trace. The dim haze of the Milky Way can disappear entirely. For someone new to skywatching, this can be surprising. The moon does not block the stars. It simply fills the sky with enough scattered light that the fainter ones are overwhelmed. It is like trying to spot fireflies beside a floodlit field. They are still there, but the contrast is gone. This means the full phase changes the character of the whole sky, not just the appearance of the moon itself. A moonless night invites you outward toward countless distant suns. A bright one draws attention back to our nearest celestial neighbor. The full moon can therefore simplify the sky, and that simplicity may be part of its power. One brilliant object steps forward, and the rest retreat into darkness. The full moon once helped travelers cross land before electric lighting, before street lamps, headlights, and illuminated roads. Darkness could limit movement in serious ways. A bright full moon changed that. Paths that vanished on moonless nights could be followed again. Rivers, gates, fences, and landmarks became visible enough to navigate by. Travelers on foot, horseback, or wagon could extend a journey that might otherwise have ended at sunset. This was especially valuable in open country, where moonlight could spread across fields and roads with surprising clarity. The moon did not erase danger, but it reduced some of the uncertainty. That practical usefulness gave moonlit travel a place in memory and tradition. Night journeys under a bright moon became part of ordinary life, not just romance or folklore. It is easy to forget how much the sky once mattered to movement on Earth. The full moon was not only something admired from a doorway, it was a working light for real people on real roads, helping them go farther through the dark. Moonlit nights shaped festivals, rituals, and timekeeping across the world. Wherever people watched the sky closely, the recurring bright phase offered more than beauty. It offered a reliable communal marker. A full moon is hard to miss, easy to remember, and visible to many people at once. That made it ideal for gatherings, ceremonies, offerings, storytelling, and the keeping of shared time. Communities could tie important events to a visible signal rather than to private records or abstract counting. The result was a deep connection between moonlit nights and human culture. Dances, vigils, religious observances, and seasonal celebrations often found their place in that cycle. The moon helped tell people when to come together. This is one reason lunar traditions appear in so many parts of the world, even where the details differ greatly. A bright full moon is public time written across the sky. It can summon a village, guide a ritual, calendar, or anchor memory across generations. The night itself becomes a kind of meeting place. In some calendars, holidays begin or end with a full moon. Not all calendars are built the same. Some rely mainly on the sun, some on the moon, and some combine both in intricate systems. In lunar or lunisolar traditions, the full phase can become a natural anchor for sacred time because it is visually unmistakable and rhythmically reliable. A holiday may be set to begin, peak, or conclude with that bright celestial signal overhead. This gives religious time a visible texture. The sky itself confirms that a sacred period has arrived. That is a very different experience from glancing at a printed date. It means astronomy enters devotion. Believers do not only remember the date, they can look up and see it. The full moon therefore becomes part of the emotional and ceremonial life of a tradition, marking moments of fasting, feasting, prayer, reflection, or pilgrimage. Sacred time is not hidden in paperwork. It is illuminated in the heavens, shared by everyone standing beneath the same bright night. Easter's date is linked to the full moon after the equinox. One of the most widely observed dates in the Christian calendar is not fixed to a single numbered day each year because its timing depends on a relationship between season and moon. In the traditional rule, Easter is set for the Sunday after the paschal full moon, which is the ecclesiastical full moon falling on or after the March equinox. That means the celebration is connected to both solar and lunar reckoning. Spring must begin, and then the lunar cycle helps determine the date. This is a beautiful example of how old religious calendars often preserve traces of skywatching even after daily life has become detached from direct observation. A major holiday still carries the structure of celestial timing inside it. The moon is not merely decorative in the symbolism of spring renewal. It is built into the scheduling itself. The result is that Easter moves across the calendar following a rule that binds sunlight, season, and moonlight into one system. The Buddhist festival of Vesak is tied to a full moon. Across much of the Buddhist world, Vesak is one of the most sacred observances of the year, and its timing is linked to the full moon of a particular lunar month. Traditions vary by country and calendar, yet the full phase remains central to the occasion. This connection gives the festival a special atmosphere. The night sky itself becomes part of remembrance and devotion. Vesak is associated in many traditions with the birth, enlightenment, and passing of the Buddha, which gives the full moon a role not only in keeping time, but in framing one of the most meaningful spiritual observances. In the Buddhist calendar, temples may glow with lanterns, prayers may continue into the evening, and the bright moon above can feel like part of the ceremony rather than a separate backdrop. Here, the lunar cycle is not merely historical residue, it remains alive in practice. Sacred memory and celestial rhythm continue to meet under the same luminous sky. The Autumn Moon Festival celebrates the full moon in several Asian traditions. In many parts of Asia, the full moon of autumn is not simply noted. It is welcomed with celebration. Families gather, special foods are shared, lanterns glow, and the moon itself becomes the focus of appreciation, gratitude, and reunion. The details differ across regions and traditions, but a common feeling often runs through them. The bright autumn moon is linked with harvest, abundance, family, and the beauty of the season at its turning point. What makes these festivals especially moving is that they combine sky watching with human closeness. The moon is admired not in isolation, but in company. Children look up with parents, Communities gather outdoors. Poems, songs, and stories may accompany the viewing. A celestial event becomes a social and emotional one. This shows the full moon at its most generous. It is not only an object of study or wonder, it is a reason to come together, to remember seasonal change, and to let the shared sky become part of shared life. The full moon has guided planting lore, though evidence for it is mixed. For centuries, people have looked to the moon not only for light and timekeeping, but for advice about the land itself. In many farming traditions, certain phases were thought to favor planting, pruning, grafting, or harvesting. The full moon often held a special place in that lore, because it was easy to identify and tied to visible changes in nature. Some growers believed crops with edible parts above ground benefited from one part of the lunar cycle, while root crops favored another. These ideas still appeal to many people, because they connect agriculture to a wider rhythm in nature. Yet, when scientists test such claims carefully, the results are often mixed, inconsistent, or difficult to separate from weather, soil, season, and local practice. That tension is part of the fascination. The moon clearly matters in many natural systems, but not every old belief proves equally strong under experiment. Even so, the lore endures because it gives farming a skyward dimension. Telescopes show that full moon beauty comes from violence frozen in stone. To the unaided eye, the full moon can seem smooth, serene, and almost peaceful. Put it in a telescope, and a harsher truth emerges. That bright face is a battered world. Its plains were shaped by immense impacts and ancient eruptions. Its craters were blasted open by collisions powerful enough to hurl rock across vast distances. Its surface dust was made by repeated destruction over unimaginable spans of time. The wonder is that such violence produced something so beautiful from chaos. The moon is not lovely because it escaped catastrophe. It is lovely because catastrophe wrote its history into every visible feature. Telescopes turn that idea from poetry into evidence. What seemed calm becomes scarred. What seemed simple becomes layered with episodes of collision, melting, shattering, and cooling. The full phase gathers all of that history into one bright disk. We are not looking at peace preserved. We are looking at damage preserved so completely that it became beautiful. Every full moon lets us see billions of years of impact history. The moon has no rain to wash its surface clean, no rivers to reshape it, no forests to hide old wounds, and almost no active geology to erase the oldest records. That makes it one of the great memory banks of the solar system. Each full moon puts that archive on display. Craters of many sizes overlap one another across the visible face, recording strikes from different eras of lunar history. Some belong to relatively recent events in geological terms. Others reach back toward the earliest age of violent bombardment that shaped many worlds. On Earth, much of that ancient evidence has been erased by plate tectonics, erosion, and oceans. On the moon, far more of it remains. This is one reason the full phase is so scientifically thrilling. It allows ordinary observers to look straight at a record of cosmic impacts stretching across billions of years. The bright disk in the sky is also a preserved chapter from the earliest history of our planetary neighborhood. The full moon is bright because the moon has no air to soften light. On Earth, air changes everything. Sunlight is scattered, filtered, reddened at low angles, and diffused by clouds, dust, and moisture. The moon has no such blanket. Its surface sits exposed in vacuum, receiving sunlight without weather, haze, or atmosphere to soften the glare. When that light reflects back toward us at full phase, it can look stark and clean in a way that feels different from most earthly brightness. There is no lunar sky to glow around it, no blue vault, no mist, no drifting cloud. Just hard sunlight striking bare ground and returning across space. That is part of why the full moon can feel so crisp and absolute when high in a clear sky. Its light has not been mellowed at the source. The moon's brightness is not only about reflection, it is also about the absence of anything there to blur, scatter, or cushion the light before it leaves that airless world and begins its journey to Earth. Moonlight reaches Earth in just over a second from the moon. That fact compresses an enormous distance into a surprisingly small travel time. The moon is far enough away to feel remote, yet light moves so swiftly that the journey from lunar surface to your eyes takes only a little more than 1 second. In practical terms, that means when you look at the full moon, you are seeing it almost as it is now, at least by cosmic standards. Not instantly, but very nearly. This makes moonlight feel strangely intimate. It is cross space, reflected from another world, and still arrived with almost no delay that a human being could notice. Compare that with starlight. Some stars we see tonight sent their light years ago. Some galaxies sent theirs long before humans existed. Against that scale, the moon is our nearby companion. Its light is quick enough to feel immediate, yet distant enough to remind us that even the closest worlds in space are separated from us by astonishing emptiness. The full moon we see is already a tiny bit old. Nothing in the sky is seen in the exact present because light always needs time to travel. For the moon, that delay is only a little more than a second, which is tiny in everyday life, but still real. So, every bright full moon is already history by the time it reaches your eyes. You are seeing it as it was a moment ago. That may sound minor, yet it carries a profound lesson. Even our nearest celestial neighbor belongs to the past by the time it is visible. Astronomy is always an act of delayed seeing. With the moon, the delay is short enough to feel almost immediate. With stars and galaxies, it becomes vast enough to cross years, centuries, or ages. The full moon is therefore a gentle introduction to one of the deepest truths in space science. Looking outward also means looking backward. The difference is small here, but it is still enough to remind us that light is always carrying time with it. Earthshine vanishes at full moon because the moon already blazes with sunlight, but in crescent phases, careful observers can sometimes see the dark part of the moon faintly glowing. That soft, ghostly illumination is Earthshine, sunlight reflected from Earth onto the moon, and then back to us. It is a beautiful effect, but it disappears at the full phase. The reason is simple and elegant. When the moon is full, from our point of view, Earth would appear nearly dark from the moon. The geometry has flipped. Earth is no longer shining strongly onto the lunar night side, and in any case, the moon's sunlit face is already so brilliant that any faint extra glow would be overwhelmed. This creates a lovely symmetry between Earth and moon. When we see a crescent moon, the moon sees a brighter Earth. When we see a full moon, the moon sees a darker Earth. That hidden partnership gives the phases extra depth. The full moon seems self-sufficient, yet its appearance is still part of the larger dance between two worlds. The full moon can sit beside bright planets and still outshine them all. Planets can be dazzling. Venus can blaze in twilight. Jupiter can shine with steady authority. Mars can burn with its rusty glow. Yet when the full moon appears near them in the same stretch of sky, the balance shifts immediately. The moon dominates, not because the planets are unimpressive, but because the moon is so overwhelmingly bright by comparison. This can make for a wonderful sky scene. A bright planet beside the moon gives scale to the encounter. It reminds us that these are not fixed decorations, but separate worlds sharing our view for a while. Even then, the moon commands attention with almost effortless ease. That visual hierarchy tells an important story about distance and reflected light. Some planets are far larger than the moon, yet they are much farther away, and usually appear as brilliant points rather than broad disks. The full moon, by contrast, arrives as a world you can see with your own eyes, rich enough in light to make other worlds look modest beside it. Even Venus looks modest beside a clean, high full moon. Venus is often called the evening star or morning star because it can shine so brilliantly that people mistake it for something more than a planet. It can cast shadows under perfect conditions, and it often becomes the first bright object visible after sunset. Yet, set a high full moon nearby in a clear sky, and Venus suddenly seems restrained, almost delicate. That contrast is astonishing, because Venus is one of the brightest objects in the heavens. The moon simply occupies a different category of presence. It is not a bright point. It is a bright world spread across a visible disk large enough to reveal shape, markings, and overwhelming radiance. Seeing Venus diminished in that company helps calibrate the eye. It shows just how powerful the full moon really is. One of the sky's great lights can stand beside it and still appear secondary. The full moon does not merely participate in the night sky. It takes command of the whole scene. A full moon near the horizon can shimmer through heat like a mirage. When the moon is low, its light passes through a thick layer of atmosphere that may be full of moving pockets of warm and cool air. Those shifting layers bend the light slightly in changing ways, which can make the lunar edge tremble, ripple, or blur. Over hot ground, roads, rooftops, or desert air, the effect can become especially striking. The moon may seem to wobble as though it were reflected in water. It can flatten, stretch, or flicker at the edges. This is the same basic kind of atmospheric distortion that helps create mirage-like effects on Earth. And it reminds us that the horizon is one of the most dynamic places to watch the moon. A low full moon is never just the moon. It is the moon filtered through the restless lower atmosphere of our own planet. That is why moonrise can feel so alive. The sky is not presenting a static image. It is presenting a world through moving air. Atmospheric turbulence can make the full moon ripple, wobble, or flash with color. Even on a clear night, the air above us is not still. It is full of shifting layers with different temperatures and densities, and each layer bends light a little differently. When full moonlight passes through that restless air, the bright disk can seem to quiver, wrinkle, or dance at the edges. Sometimes the effect is mild, and sometimes it is dramatic enough to make the moon look almost liquid. Under stronger turbulence, tiny flashes of color can appear along the rim as the atmosphere briefly separates the light into different hues. This is especially noticeable when the moon is low, but it can happen higher up as well. The sight feels strange because it reminds us that the sky is not an empty window. We are always looking through a moving ocean of air. The moon itself remains steady in space. The trembling belongs to our atmosphere, which can turn a solid world into a wavering image, with nothing more than invisible motion. The full moon marks one phase in a cycle of constant motion. It is easy to treat the full phase as a destination, as though the moon arrives there and rests. But nothing about the scene is still. The moon is orbiting Earth. Earth is turning. Earth is also moving around the sun. Meanwhile, the angle between sun, Earth, and moon keeps changing from hour to hour, which means the bright round face is only one moment in a larger sequence. Before it, the moon was swelling toward fullness. After it, it begins to wane. This gives the full phase a special kind of beauty. It feels complete, yet it is really a passing position inside continuous motion. The moon is not posing for us. We are catching it mid-journey. That idea can make the sky feel more alive. Even the most familiar lunar night is part of the ceaseless celestial process. The full moon is not a static object in time. It is a moving moment that only looks still because we are moving with it. Between one full moon and the next is about 29.5 days. That repeating interval shaped human timekeeping long before clocks and calendars became everyday tools. The cycle is long enough to feel substantial and short enough to follow with bare eyes from one month to the next. A child can notice it. A farmer can work by it. A community can build traditions around it. That span also explains why the moon slips through our calendar rather than fitting neatly into it. The cycle is not an even whole number of days, so full moons drift across dates and seasons in a way that keeps them familiar, yet never perfectly fixed. There is something deeply satisfying about that rhythm. It repeats with remarkable faithfulness, but not with mechanical tidiness. The moon returns, though never pinned exactly to the same page of the month. That slight mismatch is part of the charm. It keeps lunar time feeling organic, as though it belongs to the sky first, and to our systems of counting only second. That repeating span is called a synodic month by astronomers. The phrase may sound technical, but it describes something wonderfully simple. It is the interval needed for the moon to return to the same phase as seen from Earth, such as full moon to full moon. The important point is that this is not exactly the same as the time the moon takes to complete one orbit relative to distant stars. While the moon is circling Earth, Earth is also advancing around the sun. So, the moon must travel a little farther to line up into the same phase again. That extra catch-up time creates the cycle we notice in ordinary life. The term synodic gives a precise name to a familiar rhythm that people tracked long before astronomy formalized it. This is one of the pleasures of science, language at its best. It sharpens it. A common sight in the sky turned out to rest on a subtle piece of orbital timing hidden inside an everyday word, like synodic. The full moon never belongs to one nation, language, or century. Empires rise and vanish. Borders move. Languages branch, merge, and disappear. Yet the full moon keeps returning above all of them. People separated by culture, religion, and history have all given it names, meanings, songs, warnings, calendars, and prayers. No single tradition can claim it entirely, because it has always been present to more than one world at once. That gives the full moon a rare kind of dignity. It belongs to human experience without belonging to any one human group. A king may look up at it. So may a shepherd, a prisoner, a sailor, or a child in a city apartment. The same bright disk crosses every age and every social boundary. This is one reason the moon feels larger than astronomy alone. It is also a shared inheritance. Long before global communication, people who would never meet were already living under the same recurring light. The full moon is one of humanity's oldest common references, and it remains so now. People separated by oceans still look up at the same full moon. That thought carries an unusual kind of comfort. Two people may live on opposite coasts, in different countries, or on separate continents, with no shared language at all. Yet when the moon turns full, both can look up and know they are seeing the same world. Not an image of it, not a symbol of it, but the very same object hanging in space above Earth. Of course, the moon may rise at different times for them, or set in a different part of the sky, but its identity is shared. This makes the full moon one of the most direct connections between distant human lives. It is a real common point in the heavens. For thousands of years, that mattered emotionally as well as practically. Lovers, migrants, pilgrims, soldiers, and travelers have all taken comfort in the thought that someone far away might also be under that same light. The moon does not erase distance, but it gives distance, a visible bridge. Yet the full moon appears upside down from opposite hemispheres on Earth. People often assume the moon has one fixed appearance everywhere, but our view depends on where we stand on the globe. Observers in the northern and southern hemispheres look at the moon from different orientations, so the familiar pattern of dark plains and bright islands appears rotated. What seems upright in one hemisphere can look inverted in the other. This is not because the moon changes its orientation. It is because we are standing on different sides of the curved planet, each bringing a different sense of up and down to the sky. The effect can be delightfully disorienting when you first see it in photographs or while traveling. The same full moon suddenly looks like a cousin of itself rather than a perfect copy. That change is a beautiful reminder that skywatching is always local in one sense, even when the object being watched is shared by the whole world. Our planet quietly turns viewpoint into variation, and the moon reveals it. From the moon, Earth would show a dark new Earth at full moon. The phases of Earth and moon are mirror images seen from opposite sides of the space between them. When we on Earth see the moon fully illuminated, an observer standing on the near side of the moon would see Earth in the opposite phase, which means Earth would appear nearly dark. The bright side of our planet would be facing mostly away from the moon at that moment. This reverses the usual intuition in a wonderfully elegant way. A brilliant full moon in our sky corresponds to a new Earth in the lunar sky. If you were standing there, the land around you would glow under sunlight reflected from the moon's bright face as seen from Earth. If our own world would hang above as a dim disk, with perhaps only a slender rim of light, the idea deepens the relationship between the two worlds. The phases are not isolated events. They are linked perspectives in one shared geometry. Each phase on one world, answering another on the other side. Astronauts saw full Earth from lunar orbit. When we saw a new moon, one of the great visual gifts of the space age was the sight of Earth rising above the lunar horizon. Bright, cloud-swirled, and alive with color against black space. When astronauts were near the moon at a time, we on Earth saw a new moon. They could look back and see Earth nearly full. Oceans, weather systems, continents, and white cloud bands turned our planet into a luminous globe far brighter than the moon ever appears to us. This reversal is thrilling because it lets us imagine the Earth-Moon relationship from the other side. The phases do not belong to the moon. Earth has them too. And from lunar orbit, our planet becomes the more dazzling object by far. For astronauts, that sight was not only beautiful, it was unsettlingly intimate. Home appeared whole, suspended in darkness, while the moon beneath them was stark and silent. The full Earth from lunar space remains one of humanity's most profound and humbling views. The full moon feels timeless because it links deep space with ordinary nights. That may be its greatest power. The full moon belongs to astronomy, geology, gravity, and deep time. Yet, it also belongs to evening walks, bedroom windows, quiet roads, and the simple act of glancing upward after sunset. It is both cosmic and domestic at once. A world shaped by ancient impacts hangs above laundry lines, rooftops, fields, and sleeping towns. Sunlight travels across space, strikes an airless surface, and returns to illuminate an ordinary human night. Few other things connect those scales so effortlessly. The full moon asks almost nothing of us. No telescope is required. No special training is needed. And yet, what it offers is immense. It places another world into common experience. That is why it feels timeless. Generation after generation can meet the same bright face and feel both the smallness of human life and its strange privilege. We live on a planet where deep space regularly enters the evening and becomes part of home. Tonight, we followed the bright path of the full moon across science, history, and human imagination. We explored how that glowing disk is really a world from an airless world of dust and stone. We looked at the hidden geometry that creates the full phase and the long, slow dance between Earth and moon that shapes tides, lengthens our days, and slowly nudges the moon farther into space. Along the way, we wandered through moonlit fields, ancient calendars, coral reefs that release life in lunar rhythm, and cultures across the world that gather beneath the same bright sky. We saw how the moon has guided travelers, inspired poets, puzzled scientists, and quietly watched over generations who looked up in wonder, just as we still do tonight. And perhaps that is the most remarkable thing of all. The full moon connects deep space with the ordinary moments of life. It shines over oceans and forests, over cities and quiet roads, over people who may never meet, yet share the same light drifting across the sky. So now, the journey slows. Let the images fade into the calm rhythm of the night sky. Imagine that pale world rising gently above distant hills. The air is cool. The land is quiet. The moon hangs steady in the dark, and there is nothing you need to do except rest. If you enjoyed this peaceful exploration, you are warmly invited to like the video, subscribe, or share a thought below. It helps other sleepy wanderers find their way here too. And if you happen to still be awake, another gentle journey is waiting for you on the screen. But for now, allow the day to soften and drift away. Sleep well and good night.